Hey guys, last lesson of chapter 4, so we're going to jump into lesson 4.9. All right. Okay, so first, finite differences, which we've talked about finite differences in other lessons. The difference of consecutive y values in a data set when the x values are equally spaced. So equally spaced x's such as -3, -2, -1, 0, 1, 2, 3, all a difference of 1. And then what we do is we find the differences of the y values. If the first difference is constant, we know the data is linear. If the second difference is constant, so the differences of the differences, then the data is quadratic. If we have to go to the third differences to get the constant, then the data is cubic, and so on and so forth, okay? Properties of finite differences. If a polynomial function f of x has degree n, then the nth difference of function values for equally spaced x values are non-zero and constant. So that just means if it's a third degree polynomial, then the third difference would be constant because it's cubic, okay? If it's a fourth degree polynomial, you'd have to do the differences 4 times till you get the constant, all right? So we're jumping right into the problems here where we're asked to write a cubic function whose graph passes through the given points. Okay, so let's talk about what we know as we look at this function, all right? So when we look at this function, always has to scribble the first time, trying to find where the pen is. Okay, so when we look at this, we know that the x-intercepts are -1 and +1. All right, the positive one, sorry, let's do that again. The positive one, because I just touched it, that tells me that it's a repeated solution. It tells me that in factored form, the factor has an even degree, such as a 2 or a 4, depending on how many, what the degree of this function is. It says it's cubic, right? Write a cubic function. So it means I should have 3 factored forms. It should have a degree of 3 when it's in expanded standard notation, okay? So in factored form, f of x is going to equal, I know that my factors are x plus 1, because when I set this equal to 0, it gives me a -1, and then x minus 1 and x minus 1, right? Because I said it's a repeated solution. It is a cubic function, so there should be 3 answers, and there are, right? If I set each of these equal to 0, I get -1, 1, and 1. The one's a repeated solution, as I pointed out, because it just touches on the graph, okay? Now, because I can write that in a more simplified way, I'm going to go ahead and do that. I'm going to write it as x minus 1 squared and then x plus 1. All right, the reason I'm leaving a gap here is because I don't know what the a value is. I don't know if there is a vertical stretch or shrink. I don't know if there is a reflection. Okay, so I have to figure out what the a value is. Now, to figure out the a value, you're going to use that other point that they give you on the graph. Okay, that other point is given so that you have an x and a y value that you can plug into the function. So remember, in function notation, you can change function notation to y equals a times the quantity x minus 1 squared, x minus 2. Since you're given that point, 2, 3, that's going to be your x value and your y value. So plug in 3 for the y and plug in 2 for the x. And then, forgot the parenthesis there. And then we'll just clean it up and simplify to solve for a. So I have 3 equals a, 2 minus 1 is 1, 1 squared is 1, 2 plus 1 is 3. So then I have 3 equals 3a, divide both sides by 3, and you get a is equal to 1. Okay. Once you know the a value, a is equal to 1, I'm going to erase all this. Then I can write the function. Now, obviously, because the a is equal to 1, it's not even necessary, but it's not always going to equal 1. So I will need to know this process to figure out the a value for other problems. And there is my function. Okay. Now it does ask for, oh, it doesn't specify. I didn't know if they wanted in factored form, or it does say cubic function. So if you wanted to multiply it all out to show that it is x cubed, okay, in standard form, you could, but it's not necessary. You can just leave it in factored form. All right, so that's that first problem. Let's try another one. All right, similar setup. So my x-intercepts, are -2 and 0. -2 and 0. Are either of them repeats? So remember, the repeated solutions are the one where you just touch. Okay, if you pass through, it's not a repeated solution. So this one is your repeated solution. So because there are supposed to be 3 solutions, that means in factored form, I'm going to have x plus 2 and x plus 2 twice. And then just a GCF of an x, that's how I got that 0, right? If I set each of these equal to 0, I have, I'm going to erase all this in a second, but just to show you, I have x is equal to 0 as one solution, x is equal to -2, and x is equal to -2, my repeated solution, right? Oh, the pen's starting to go crazy. All right, so that's my factored form, but remember, I don't know if there is a, starting to go crazy on me. Are we done? I don't know if there's a vertical stretch or shrink. So I'm going to put an a there. I have f of x equals, change your f of x to a y. So I have y equals ax, x plus 2. Oh, I forgot I could write that as squared if I want, instead of writing as x plus 2 times x plus 2. And then that other point that's given, so -3, -3, that's your x and your y. So I have -3 equals a, and then times -3 times -3 plus 2 squared. Follow order of operation. So exponent first. Inside the parentheses, -3 plus 2 is -1. -1 squared is a 1. So I have -3 equals a times -3. So that's -3 equals -3a. Divide both sides by -3, and a equals 1. I promise it's not 1 all the time. I know for the first two it was. All right. Okay, so now I can erase all this now that I know what the a value is. And I have y is equal to 1x, x plus 2 squared. And again, you don't have to write that 1. If your a is 1, it's not even necessary. Okay. All right. Let's go down. Number 3, I'm trying to decide if I want to do this one. I'm going to skip this one because it's very similar to the other ones we've already done, and because the a value ends up just being a 1 again. Let's try one that it's not a 1. Let's try number 4. Okay. All right. So for number 4, my x-intercepts are -2, 1, and 3. Notice you pass through, and you pass through. None are repeated solution, which makes sense because there's supposed to be 3 solutions, and I have 3. In factored form, it's x plus 2, x minus 1, and x minus 3. I don't know the a value, or if there is one other than a 1. I'm going to write it as y equals a, x plus 2, x minus 1, x minus 3. The other point that's given, the one that's not an x-intercept, which is 0, 3, this is your x, this is your y. So I have 3 equals 0. Oh, no, a is not 0. A is what we're solving for. A, the x is 0. 0 plus 2, 0 minus 1, 0 minus 3. So inside parentheses, simplify first. You have 2, -1, negative 3. Let's do the multiplication. So I have 2 times negative 1, that's negative 2. Negative 2 times negative 3 is a positive 6. Let's rewrite it as 6a. Divide both sides by 6. And you have a is equal to 1/2. Finally, got an a value. It wasn't simply a 1. So I'm going to erase this portion just because I don't have any more room and replace the a with a 1/2. And, oh, I should have written function notation instead of y equals. So I'll go back and fix that as well. I don't remember what I did for the other problems. If I didn't write function notation, I should have. F of x equals. And there is your function. Okay. All right. So the next set of problems we're going to look at, it says use finite differences to determine the degree of the polynomial function that fits the data, then use technology to find the polynomial function. All right. So what you're going to do is you're going to figure out if the polynomial function is degree 2, degree 3, degree 4, and so on. And then I'll show you how to use your calculator to come up with the function. All right, so for the first one, if I subtract to find the differences, all right, negative 14 to negative 6.5 is a positive 7.5. And then from negative 6.5 to 0 is a positive 6.5. And then from 0 to 5.5 is a positive 5.5. Then I'm increasing by 4.5. And then I'm increasing by 3.5. Point, by the way, 0.5, 3.5. All right, now the differences there. I am decreasing by 1, decreasing by 1, decreasing by 1, decreasing by 1. So this is my first difference. This is my second difference. Because the second difference is constant, that means that this polynomial is degree 2. Okay. Once I determine that it's degree 2, I'm now going to use my graphing calculator. Don't need to know any of this anymore. Okay. So with your graphing calculator, you're going to hit stat. Actually, let's clear our calculators first in case anything crazy is going on. So second plus 712, just kind of reset and clear. Then you're going to hit stat. Go over to, or select edit, select edit, and you're going to enter the data. L1 is for your x's, so negative 2. Let's look at my paper. Negative 1, 0, 1, 2, and 3. Go over to enter your y's in L2, so negative 14. Oh, I didn't mean to hit over, sorry. Negative 6.5, 0, 5.5, 10, and 13.5. Okay, then you're going to hit stat again, go over to calculate, and since we said this was degree 2, quadratic equations are degree 2, so you go down to number 5. Quad regression. If it was degree 3, I would select cubic. Oh, that's not what I meant to hit. Let's go like this. Calculate. Sorry. So if it was cubic, I would hit number 6. If it is quartic, 4th degree, I would hit number 7. Okay. If it was linear, I would have hit number 4. Okay. So degree 1 would have been 4. But this is quadratic, so I'm going to hit 5, quad regression. I'm going to go enter and then scroll down to calculate, push enter. They give you in standard form, y equals ax squared plus bx plus c, and they tell you the a, b, and c values. All right, so, oh, and by the way, this is scientific notation 8.1 times 10 to the negative 13. So that would be 0.00000000000081. It is such a small number, we're just going to consider that a 0. Okay, so you don't even have to include that. So your function is going to be, come on, where am I? All right, so it's y equals negative 0.5, and if you want to write it as a fraction, you can, x squared plus 6x, okay? And you don't have to include the c value because it's so small, we're just gonna say it's 0, okay? So that's number 5. All right, 4, I'm just gonna do one more. I'm not gonna do all of them because it's all the same, right? You just have to figure out what it is and then plug it into the calculator. So let's go to number 7. We'll do number 7 and then we'll be done. You guys can do 6 and 8 on your own. I'll tell you for 6, you should find that it is cubic. And for 8, you should find that it is degree 4 quartic, okay? But let's go to 7 just for one more example. So this one, it's not set up as a table. If you find it helpful, you can absolutely set up your own table with these values. Like if you find it easier when you're plugging in the values. So 0, 0, right, x, y, then 2, 0, then 4, 0. That, oh, what am I doing? Sorry, hold on. Try that again. Try that again. I don't know what I was doing. Okay. So it's 0, 0, then it's 2, 0, then it's 4, 40, then it's 6, 168, then it's 8, 432, then it's 10, 880. All right. So change is 0, change is plus 40, change is plus 128, change is plus 264, change is plus 448. Definitely not linear. Changes 40, changes 88, changes 136, changes 184. All right, let me just go like this so we don't get confused with where we started. Okay, now I have a change of 48, a change of 48, and a change of 48. So first would be linear, second quadratic, third cubic. So this is degree 3. Degree 3. So in my calculator, I'm going to hit stat. I'm going to select edit. To clear your list, go up to highlight L1, push clear. It doesn't look like anything happened, but when you go back down, it's empty. Go over, go up to L2, push clear. When you go back down, it's empty. L1 is for your X's, so 0, 2, 4, 6, 8, 10. And then your Y, corresponding Y's are 0, 0, 40, 168, 432, and 880. I think that's the right number, 880. Yeah. Then you're going to hit stat. You're going to go over to calculate. We said it was degree 3, so cubic regression. Go down to calculate, push enter, and it's going to give you your polynomial function degree 3 because it's cubic, A, B, C, and D values. Because D is 0, you don't need to include it. All right, so let me erase. Oh no, that's not what I meant to do. Oh, well, good thing I have it written down on my paper, so I can just look at my paper since I clicked on the wrong button. All right, so my function from my calculator that I made disappear is f of x equals x cubed minus x squared minus 2x. If you want to include the coefficients of 1, you can, but it is not necessary, and you don't have to add that plus 0. Okay? All right, guys, that is it for this lesson. Like I said, you can always try numbers 6 and 8 for more practice, just to make sure you're okay with your graphing calculator. But that is it, and that brings us to the end of chapter 4. So I will see you back here for our next lesson. Bye.